morning to everyone. Welcome back to ACT Mathematics class 12th. In this chapter 5 continuity and differentiability, last minute revision. What are the important quick revision? Let's see in this chapter. Okay, a function f of x is said to be continuous. That means continuous definition, this one. A function f of x is said to be continuous at x equal to a if limit x is approaches to a, f of x equal to limit x approaches to here a negative and x is approaches to a positive value a plus f of x equal to f of a, that is LHS left hand side limit equal to right hand side limit. F of a is the value of the function at a, that is limit x tends to a, f of x equal to a. This is the continuous function. Okay. Next, if f of x is not continuous at x equal to a, we say that f of x is discontinuous at x equal to a. F of x will be discontinuous at x equal to a is any one of the following cases. So here first case is limit x is approaches to a minus f of x and limit x approaches to a plus f of x is exist but both are not equal. So that's why the given function f of x is said to be discontinuous at x equal to a. Limit x is approaches to a negative f of x and limit x is approaches to a positive f of x is exist and are equal but not equal to f of a, both are but not equal to f of a. F of a is not defined. F of a is not defined. At least one of the limits does not exist. At least one of the limits does not exist. So in this all cases, if any one case is possible, then we say that f of x, the given function f of x is said to be discontinuous at x equal to a. Okay. Next, properties of continuous functions. Next topic is properties of continuous functions. Let f of x and g of x be functions both continuous at x equal to a, then c into f of x is continuous at x equal to a where c is any constant. So f of x plus or minus g of x is continuous at x equal to a. F of x into both continuous functions f of x and into g of x product is also continuous at x equal to a. And division, these are the properties of continuous functions algebra. Okay, f of x by g of x is continuous at x equal to a is provided g of a is not equal to 0. These are the properties of continuous functions. Next one, differentiability. So continuous topic last minute revision is over. Next topic is differentiability. Let y equal to f of x be a continuous function of x in open interval a comma b, then the derivative or differentiable quotient of f of x with respect to the x at x belongs to open interval a comma b denoted by d by dx or f dash of x. So d by dx is differentiability of y equal to f of x, okay, or another one is f dash of x is dy by dx equal to limit delta x approaches to 0 f of x plus delta x minus f of x by delta x. So this is the general form of the differentiability. Okay, provided the limit exists and is finite and this value also finite and the function is said to be differentiable. So the given function is said to be differentiable. So this is the general form of the differentiability. Okay, to find the derivative of f of x from the first principle, if you obtain the derivative of y equal to f of x using the formula dy by dx equal to limit h approaches to 0 f of x plus h minus f of x by h, we say that we are finding the derivative of f of x with respect to x from the differentiation or from the first principle. So this is the first principle of the derivative of f of x. Next one, left hand derivative. Left hand derivative of f of x at x equal to a is denoted by L f dash of a or f dash of a minus and is defined as limit f dash of a equal to limit h approaches to 0, h tends to 0, f of a minus h minus f of a by minus h is here greater than 0. Clearly f of x is differentiable at x equal to a if and only if r into f dash of a, that means right hand derivative is equal to left hand derivative L into f dash of a. If the function y equal to f of x is differentiable at x equal to x naught, it must be continuous at x equal to x naught. A function which is continuous at x equal to x naught may or may not be differentiable at x equal to x naught. Next one, Rule's theorem. So what is the Rule's theorem? If a function f of x is first one is continuous in a closed interval closed a comma b, differentiable in the open interval open comma open bracket a comma b. Third one, f of a equal to f of b, then there exists at least one value c belongs to a comma b such that f dash of c equal to 0. Next theorem is Lagrange's mean value theorem. If a function f of x is continuous in a closed interval closed a comma b and second one is differentiable in the open interval is a comma b, then there exists at least one value of x equal to c belongs to open interval a comma b such that f of b minus f of a by b minus a equal to f dash of c limit value. Okay, so this is the Lagrange's mean value theorem. So thank you. These are the last minute quick revision.